हाय माय नेम इज़ मनोरमा। मैं आपको तनाबे सुगानो डायग्राम के बारे में एक्सप्लेन करूँगी। A Tanabe sugano diagram is a graphical representation that shows the variation of electronic energy level of transition of metal complexes as a function of the crystal field strength. It helps in understanding electronic transition, absorption, spectra, and the effect of ligand field strength on the electron configuration. It is mainly used to predict electronic spectra and stability of octahedral and tetrahedral complex. A graphical representation showing how the electronic energy level of transition metal complex weigh with crystal field strength. Understanding electronic spectra and term splitting in transition metal complexes. X-axis crystal field strength and y-axis energy of electronic state. Recap parameter represent inter-electronic repulsion between the electron. Crystal field splitting energy represent the energy difference between T2Z and EZ orbital in octahedral curve. Each curve shows how a particular electronic term energy changes with increasing crystal field strength, and cross point show how where one electronic state become more stable than another, applicable for both octahedral and tetrahedral complex. Recap parameter denoted as A, B, and C are constant used to describe the electron repulsion metal electron. They help quantify how strongly the electrons repel each other and are used in the calculation of energy level in Tanabe-Sugano diagram. Key points: A, B are the three recap parameters. B and C represent inter-electronic repulsion between the electron. Electronic configuration in Tanabe-Sugano diagram. Tanabe-Sugano diagram are for transition metal ions are so we considered their d electron configuration. The configuration is usually written in the free ions from example D2, D3, D8, etc. The diagram show how the energy of different electronic term arising from this configuration changes as the crystal field strength varies. High spin, weak field, and low spin, strong field state depend on the splitting of d orbital. D2 octahedral complexes. Term the symbols show how the spin and orbital state of electron in the free ion configuration. Each curve is Tanabe-Sugano diagram correspond to a particular term symbol. When the crystal field is applied, the term into sublevel and their energy changes, leaving inside spectral transition D2 octahedral complexes. Term splitting in octahedral. Free ions have atomic term depending on their d electron configuration. When placed is in an atom crystal field, this term is split into sublevel due to interaction of d electron with ligand. The splitting depend on the strength of the crystal field. Example D2 configuration under octahedral field. Key points: high spin and low spin state, weak field high spin, less splitting, strong field low spin, more splitting. Tanabe-Sugano diagram plot energy of term versus crystal field strength. Tanabe-Sugano diagram step: identify the d electron configuration, determine the number of d electron in the metal ions. Example Fe3 plus d5. Determine the free ions term using Hund's rule and spin orbital coupling. List possible term. Identify octahedral or tetrahedral field. Decide whether the complex is octahedral or tetrahedral. This affect the splitting pattern of d orbital. Draw the axis: y-axis, x-axis crystal field strength and y-axis energy of electron state. Plot the free ions term. Start from weak field where all term have energy EB E by B related to Ricke parameter B. Apply the term splitting rules. Split free ions term into subterm according to octahedral or tetrahedral symmetry. Use group theory or standard splitting tables. Draw energy curve for each subterm as increase curve show how energy of each term changes with crystal field strength. Identify how spin and low spin state, weak field, high spin, strong field, low spin crossover indicate a spin state changes. Analyze transition. Vertical line between curve indicate possible electronic transition spectra. Example the example of Tanabe-Sugano diagram for D2 octahedral complexes. This is an example of TS diagram for D2 octahedral complex.